Anthony Fulford. I'm with the University of California Cooperative Extension, and I'm here at the USDA NRCS Plant Materials Center in Lockford to show you how to measure water infiltration. Now, water infiltration is a physical property that supports soil function and helps maintain soil health. Soil health is the continued capacity of the soil to live and function in such a way that it supports the needs of animals, plants, and humans. As land managers, we can positively impact soil health by implementing management practices that keep the soil covered, maintain roots in the soil year-round, minimize soil disturbance, and enhance plant and animal diversity. Now, these management practices are known as our soil health principles, and they help align our management approach with our desired soil health outcome. Now, before we start kind of changing up our management approach in order to reach our soil health outcomes, we need to have a good understanding of the functional capacity of the soil in the field. So today, I'm going to be going over how to take a water infiltration rate measurement, because infiltration is largely determining how that soil is functioning as a regulator of water and nutrient movement. So I'm standing here in our field border trial, where we're evaluating how the establishment and maintenance of plants along the field's edge is impacting the soil's physical condition and overall health. We established this trial here in the fall of last year when we planted a beef forage mixture of mustards, creeping wild rye, and companion sod grasses, each in different plots. Now, the above ground growth of these plants as well as the below ground growth is very different. So we're wanting to use measures of water infiltration to kind of reveal how our plant management practices are impacting the soil's physical condition and structure. If we're positively impacting the soil structure, then we should see increases in water infiltration rates, which could lead to further improvements in plant growth. So today, I'll be going over the equipment you'll need and the steps that are required to take a water infiltration rate measurement in the field quickly and easily. We only need a couple pieces of equipment, so let's get started. So we're going to be measuring water infiltration in an unsaturated soil using a mini disc infiltrometer. Now, the mini disc infiltrometer is a very simple tool. It only has a couple components, and its small and compact form allows it to be transported in and out of the field very easily. So the infiltrometer itself is composed of an upper chamber and a lower chamber. There's a tube that runs throughout the lower chamber, and this helps regulate water flow. There's also a tube in the upper chamber, and this helps regulate the suction or the tension that the water is held at. And this will be adjusted based on our soil texture. Now, the only other component of the infiltrometer is the base. And the base contains a porous steel disc, and this allows water to move out of the lower chamber and into the soil. So in order to complete this measurement, besides the infiltrometer, you'll need a container of water, a stand with an adjustable clamp, a notebook for recording the data, and a timer or stopwatch on your phone. So now, before we move into the field to take our first measurement, we need to assemble our equipment. So we'll start by filling the upper chamber with water. I want to fill it to about 3/4 of the way full. That will work right there. And then I'll grab the cap and place this on the upper chamber. I'll secure the cap and make sure the suction tube is pressed all the way down so that it touches the top of this chamber divider. Now I can flip it over and fill the lower chamber with water. In the lower chamber, I'm trying to get about 90 milliliters of water in that lower chamber. The lower chamber is marked along the side in 10 milliliter increments. It has a maximum capacity of 95 milliliters. Now, the exact volume in the lower chamber right now is not so important. We just want to get between 90 and 95 milliliters of water in that chamber. We'll make sure we get the exact measurement before we move out into the field. So, now one thing to note, however, is that I'm just using regular tap water here. I'm not using distilled water, because distilled water could disperse clay, soil particles, and other fine material in the soil and artificially alter our water infiltration rate measurement. So just using tap water here is the preferred and recommended method. So now I'll just go ahead and pop back on the base cap. I'll secure that in place. And now we're ready to move into the field to take our first measurement. As we move into the field, we're looking for an area that's relatively level and flat and clear of a lot of surface residue. Now, when we find our appropriate sampling location, we'll need to adjust the suction tube in the upper chamber. As I mentioned earlier, this will be adjusted based on the soil texture you're working with. So in most cases, having this set at a 2 centimeter suction will be appropriate. However, if you're working in a sandier soil, you're going to want to increase that suction above 2 centimeters. Whereas if you're working in a heavy clay soil, you're going to want to decrease that to less than 2 centimeters. So the best approach here is to consult with the web soil survey, see what soil texture you're working with, and make the appropriate adjustments. Here in our field border trial, we're working on a sandy loam soil, so I'll increase this above the 2 centimeter setting. In this case, I'll just use about a 3 centimeter marking on this upper chamber. So once the suction is adjusted based on your soil texture, you're ready to take the first measurement. So this is a good time to flip out your notebook and make a data table with 2 columns. One column showing your time in seconds and the other column showing the water volume in milliliters. So I'll go ahead and check the lower volume of water in this chamber, and we're about 90 milliliters, about 89 actually, so I'll include that in a notebook along with our initial time, which will be 0 seconds. So now when I place this on the soil surface, water will immediately begin to flow out of the chamber and into the soil. And so I'll record the change in water volume level every 30 seconds until at least 20 milliliters of water has leached out of the lower chamber and into the soil. Now we're going to want to keep this in place at the original point of contact, making sure we have good contact with the soil surface. So this is where having a stand with an adjustable clamp comes in handy. Once 20 milliliters of water has leached out of the lower chamber and into the soil, we can stop recording our data. And this is a good time to flip back to our notebook to make sure that in addition to the data table, we've made a note of the date, the location, the soil texture we're working on, and the suction level used to make the measurement. And this is all the information you'll need in order to determine your water infiltration. However, it is a good idea to repeat this process several times across a large area of the field and then use that as an average infiltration rate for the field. So here in the field border trial, we'll repeat this exact same process 3 more times and then average this data together. So now we can go ahead and finalize our measurement. Once all our data is collected, we'll put all that in the table and we can move from the field into the office where we can calculate our water infiltration rate. And we can do this by relating the change in volume over time to our cumulative water infiltration. And this is done most easily using a spreadsheet calculator, and the results that you get will tell you how many inches of water per hour are moving into the soil surface.
Here's an example of an online spreadsheet calculator that will take the information that we've gathered in the field and generate our infiltration rate. The data we've collected in the field, including the time and the water volume measurements, are entered into the table, and we can select the mini disc infiltrometer, the soil type we've been working with, and the suction level used to make the measurement. As data are entered into the table, the infiltration is calculated automatically. Additionally, a graph showing the cumulative infiltration over time is also generated automatically, and it's the slope of this graph that, when adjusted based on our soil texture, gives us our final infiltration rate in centimeters per second, which, when we use a conversion factor, we can convert to give us our infiltration rate in terms of inches per hour.
So today we've been looking at how to measure water infiltration using the mini disc infiltrometer. As you've seen, this method can be done quickly and easily in the field, and the information you get can help you improve your water and nutrient management. Knowing how many inches of water per hour are moving into that soil can really help tell you how that field is looking in terms of its physical condition and how that soil would be able to absorb water and nutrients. If you have a low water infiltration rate, that indicates that water movement is being restricted, possibly due to a poor soil structure or soil compaction. Whereas a high infiltration rate indicates that water applied at the soil surface, either through irrigation or precipitation, will more easily move into the soil and into the rooting zone where it can support plant growth. So I encourage you to get out into the field to measure water infiltration so you can begin to use those management practices that improve soil structure, increase water and nutrient retention, and it'll put you on a path to kind of supporting soil function and really building up those healthy soils that we all want. So thank you very much. If you have any more questions or would like more information, please reach out to your local extension office or contact me directly through the Stanislaus County Extension Office in Modesto.